Good afternoon, everybody. Thank you for sticking through a 4 o'clock presentation. I hope my voice lasts through this. My name is Lloyd Colegrove. I'm the Director of Fundamental Problem Solving and Statistics and Modeling at the Dow Chemical Company. And in my spare time, I like to vision about what I'd like my company to do in the data space. And there's several people in the audience from my company who have not seen this yet, so this is going to be an interesting conversation. Andy yesterday mentioned intelligence-based manufacturing. And in that, and I think we alluded to it earlier today, we're not talking about just plant data. I'm also talking about the data systems that hold the technical reports for my company. I'm talking about something much bigger. So in the presentation today, I'm going to show you a 1-minute movie trailer on the burning platform. I will not discuss it. If you don't get it, just raise your hand. I will then go through the process that my team has gone through over the last 6 months of trying to envision what we want. We call it run design, not EMI, because I didn't know these terms back then. And my friends at Northwest Analytics are trying to coach me in the right terms for this audience, because I'm a chemical physicist by trade, by the way. I don't know anything about computers. And we're going to take you through that thought process of what we're looking for. Then we're going to show you how we're using some capabilities out of Northwest Analytics to get us down the road towards what we envision in the future. One little marker about my slides, I will talk to you about what is and what I'd like to have and what will be. If I'm talking about the I in the left-hand corner will not be there. If I'm talking about what I want, the I will be there. So if I say something and you think, oh my goodness, they've done that, if the I is on the slide, it is not so yet. So very quickly, because I've sat through several great enterprise talks just today alone this morning, in my company and in a lot of companies, we have data systems that run process control or monitor safety or product release. There are lots of different things that they can be doing, but they are not combined. They are not necessarily looked at together unless there's a problem in the plant, and my fundamental problem solvers need to go in and find out what the root cause might be. And so very simply, what I would like to do is bring all those databases together in some sort of enterprise setting to do the things it's supposed to do, but also help me run not only that one plant, but a bunch of other plants just like it. I want to bring together all the resources to look at the data, and in this case, I don't want a cloud to do it. I want my data to stay where it's formed. I want it to live there. I want it to thrive there, but I want the cloud, I guess, in a sense, to be the analytics that are going to do what I want to do. I have great analytic capabilities in my groups, but it's all done manually because we have to go out and get the data. And so what I'm going to talk to you about today in run design is something I would like way off in the future, where instead of me having to work for the data, I want the data to work for me. So, what's our motivation? Well, we'd like to justify our actions to fix, guide to improve, prescribe actions to make breakthrough changes. We've got some quotes on here. I've got a few of these in the things. The largest impediment to becoming more data-driven is lack of understanding of how to use the analytics. Well, I just told you I've got some really bright people. They're engineers and advanced statisticians. They know how to use their analytics, so therefore I need to figure out how to get them to give me capabilities that will cause me to listen to my plants, listen to my processes better than I'm doing today. Because listening to my plant is not looking at the quality assurance metrics out of the lab or making sure that the pumps are running properly. It's more complex than that. Oops. So when we get to that point where the analytics are working for us and we're not having to work so hard to get there, that's what we refer to as our run design space, which the rest of you all, it's EMI, which I will try to get there someday. Now, we not only make films, we also draw cartoons. And so you're going to see a couple of these cartoons through here. There's not really something you need to read. You really just need to listen to my story, I guess. But the first thing we needed to do was I needed to come back and ask some fundamental questions about what's going on in my really large company. And that is that the data systems we have today were designed 40 or 50 years ago. How we view our data today is something that came out of processes and business procedures and running plants. And frankly, we're still doing things mostly the same way we did today as we did before computers were as common as a salt shaker on your table. You can say that we're better and faster at a lot of things, but I don't know that we at least around my backyard, I don't know if we've actually stopped to consider that the data needs to be different than it is today. so that we can actually service all the different users of the data on the right-hand side. So that space in the middle is the EMI to me, and what we're trying to do is make sure that the needs of the businesses or the people in the plants are met, but not just with plant data. I also want the new people in the plant to get data out of our library of papers and technology and science. And frankly, I'd like that to show up on their desktop immediately after the system tells them that, hey, you've got a data anomaly we've detected, and by the way, it's related to this particular paper. So remember that picture. Now, I'm not going to go through all of this, but if you'll go with me for just a minute, in the far future, if I'm in run design, a bunch of these things will be happening automatically. I'll talk a little bit about why assertive analysis, which we all rely on in the manufacturing world, is archaic, it's useless, and there's better ways of doing things. And if we were in run design, in my definition of it, or EMI, we'd be accepting specifications out of process capability, multivariate analysis. Design of infrastructure, and we'd establish new rules for how the data lives. Our data systems would be making decisions for us. All data systems within a plant would be integrated. Future technical developments in data analysis would be implemented in architecture without crisis. You've heard, I think this morning, that Dow's going through a new version of SAP, and it's causing a lot of trouble in the company, right? It's a real tumultuous change. Why is it that doing this is creating so much angst in our company? And then we'd learn how to listen to our signals better, and it would mean something different to our plants, our technology centers, our senior business leadership. All of these things that EMI is ultimately designed to deliver. So, as an example, today I can quantify on as many dimensions as you want the process capability of a plant. If I have 7 or 8 quality measures, we can go in with advanced chemometrics, we can do our analysis, and we can draw you an n-dimensional figure. In 3 dimensions, it can look like something. And I can now control what goes out of my plant by looking at that model and knowing exactly when I'm out of normal in the plant. Not out of spec, but out of normal. I could go to a customer and tell them, if you'll accept that mathematical model, we can dispense with all the other specifications, and I'll tell you I won't leave that space. We've published papers on this in the past. Right now, we're handing a piece of paper to people and saying, take this as our certification of our product meeting your needs. But mostly that piece of paper goes sliding into someone's desk drawer. So this is something that we'd like to see moved in an EMI situation, and we have ways of doing it. This is a very interesting example. This is a very complex graph. I'm not going to describe what it means, and we've actually hidden a bunch of stuff in it. But we just did this about a month ago, and we did this to try to make a point to a plant. And the point is really this, and by the way, it takes about 2 or 3 hours to put this together. That little graph right there, that little line, is the right-hand axis is the axis you should be looking at. Any number below 100 is product, perfectly good product that's being flushed down the drains out to a biopond. The plant's been doing this for years and had no idea. Well, in my future world, we'll be able to program capabilities like this in there so that mathematical algorithms will start looking for that kind of capability. The plant was absolutely dumbfounded when they saw this, and they're taking measures to try to fix this. And finally, the last example I'm going to use here in this fictional space we're in, we all know what a control chart is, but we should be looking at our control charts in a multivariate sense. We need to be looking for the correlations between them. There's a whole matrix. We do this manually in my groups now. I want to get this programmed into the space where we can start doing this across the enterprise, between plants, between operations within the plant. Control charts, don't get me wrong, are great information, but we simply don't specify the correlations between different variables that happen to be correlated. By the way, lack of correlation is also a good thing sometimes, and we need to take more advantage of that. I love this quote from Clay Sharkey. It's not information overload, it's filter failure. And we've talked a lot about how much we have so much information. I've had people tell me they want to see it all. I don't want to see it all, but I want to be smarter about what I do look at. So we're going to call out relationships. Now, oops, that wasn't supposed to happen. So let's get started with the actual thing we're doing now. So this is real. The lie disappeared. About a year ago, one of my colleagues came back and said, okay, if we want to start moving down this pathway, what do we need to do? We need to retrieve data, join data, and analyze data. Now, it says nothing about the data that I want to get out of our technology papers and all the other things out there, but it's pretty basic format. And the way this works is the retrieved data is the services layer. The service layer will know how to interact with all the databases. It will discover what is available. It will retrieve data. Then we want to join the data, and here we didn't know what words to use, so we called it the wonderful tool. And then, of course, we went out to try to find that wonderful tool. But it'll join our data regardless of where the data comes from, whether it's continuous, batch, multiple plants. And then, of course, I told you we're already real good at analyzing the data, but we're only good at analyzing the data when we get our hands on it. And sometimes that can take weeks to do. And so I want to get all this front-end stuff done so we can start doing the magic at the analyzed data piece. Now, what most users in this process would see is simply the top. It's the workflow implementation tool, effectively. They wouldn't have to see the rest of that because I've got the people that would take care of the piece at the bottom for them. And so this is a workflow that we were studying when my friends from Northwest Analytics showed up with a picture that was very similar, but they had fancier words in all the boxes than I did because they live in the data space, and I'm just sort of a, amateur, I suppose. So when we started down this road with them, our question was, what are our first hurdles? What are the things we have to do? The picture on the right, by the way, was drawn by one of my chemometricians because the thing that bugged him the most about working in this environment is if we have a problem in the plant, he can all of a sudden be bombarded with massive amounts of data, and it can take him a week or more sometimes to sort through it all. So that's the picture that I just put there. But that bombarding of data comes from a bunch of different instrument software, lab information systems, process historians, SAP-like data systems. It can be anywhere. And by the way, some of our analyzers in some plants are not even connected to our data historian, so it's out there making a yes-no kind of decision as to whether or not it sees anything, but I don't even see that data. We have data collected at different time intervals, and we have data integrity problems, which everybody in manufacturing has. But once we create an appropriate play space for our data, then we get to dream about what we're going to achieve. So when this started with our partner, we were already doing datas and alarms. I sat through a very interesting discussion earlier today about how they're trying to make response to alarms smarter, and it was a very, very good talk this morning. But I wasn't satisfied with the data and alarm piece within our plants, and so about 8 years ago, using quality analysts, we started running this out into the plants. I'll tell you all, our success in getting this done was because first we began to teach people what proper data analysis was capable of doing, and that excitement generated an interest in getting these kind of programs into our manufacturing. Okay, that allows us to organize data, and that turns data into information. And there was a talk this morning that follows the same theme that you're going to see below my cave people here. The next thing I wanted to do to start us to get into the EMI and get us into what I call run design is I want to turn information into knowledge. And from this, we're using the Enterprise, which as a beta test right now. And I'll tell you a little bit about the Enterprise, but we're not done testing it. We just started 3 months ago, and I'll give you a little bit of flavor for how it's doing. It's dashboards for improvement, but it's more than just dashboards. We're starting to collaborate. We had the first intervention by R&D in a plant halfway around the world when somebody walked in one morning, looked at the data on their desk in Freeport, Texas, and called the plant up immediately and said, "Why are you doing that?" Immediately, we just paid for ourselves for the first year we've been fiddling with this. It was great. Now, of course, I've got more I want to do. Automated actionable analytics. What does that mean? I have no clue. I thought I had made it up until 3 days after we made this slide. It showed up in Dilbert. Think about that a minute. It did. And so, but what that means is that basically within the data space, we will have the tools and processes available to us to do the kind of things we're doing. I'm going to slow down now just a little bit and talk to you about this implementation. On the left is how we do things today. Pretty much, we do have our Northwest Analytics quality analysts in many of our plants doing a lot more of data capture. But if we don't have it in there, there's a lot of other processes that have been cobbled together. And by the way, there's quite a few production facilities in Dow. And we spend a lot of time trying to capture the data, and we report it. And analysis kind of falls off the back end because we spent so much time trying to put this together. What we'd like to do is automate the capture of the data and spend a whole lot more time analyzing it, all right? Data plus analytics equals intelligence, and then collaboration plus intelligence equals knowledge, and hopefully at some point we'll get to wisdom, because if you remember back in the film I showed you, a burning platform is that we have a lot of people were running through our plants. We're no longer running the plants with the number of resources we did 20 years ago. And so we have to do a better job of training and providing the information people need to run the plant now, because 2 years from now there may be a new group of people in there. So with this value proposition, what we did was we have now installed Northwest Analytical Focus EMI. Now, I have been given a few tips here because I wasn't talking about it right, but I think I'm going to do this right. I'm not going to show you a bunch of dashboards and a bunch of statistics. You all have seen all that. The core EMI, which is something that we've been using around Dow for about 5 years now, is direct data source connectivity into the plants, real-time data aggregation, it's comprehensive analytics, and we have our dashboards and alarm and notification services. Our engineers for some reason still love to get emails when they're off work one day and the plant is not necessarily working real well. Oops, pardon me. I'd like to say that there's nothing special about this. It leverages existing infrastructure. The thing I like about it, because I had to have this requirement, it's agnostic to databases. I use the term agnostic, and I don't want to insult anybody, but it doesn't care what database it's knocking at the door of. It is going to be able to do a data transfer, and in a company like Dow, which is made up of a lot of different acquisitions and a lot of different companies that did not start out in Dow, you can have very different sorts of data systems and very different sorts of problems. It doesn't duplicate the data. It takes the data straight out of the plant at the time you need it, and we have noticed no disturbances in our data capabilities. And what we're going to do now is try to make it more than just accessing and analyzing the data. We're also going to make the data more visible through various opportunities to get the graphics out into a collaboration space, which I'll talk about in a little bit. And I'm really big on real time. Real time in a batch process is definitely something different than real time in a continuous process. But our continuous processes, if they are running and not running well, we can be blowing through a whole lot of money very quickly if we don't come to an answer very quickly. Now, something called accelerating services, there's a knowledge base and a collaboration center. This gets me closer to my vision that I'd like to see in run design of being able to have a space where not only is the data analyzed appropriately, but that we look for other opportunities within the data space. We can compare between plants, we can compare between unit operations, but it also engulfs a much larger group of people, not only the people in the plant who may not have a whole lot of experience if they're new to the plant, but also the R&D organizations and people in my fundamental problem-solving group, for example, that can also play in the data space real time. And then the collaboration center comes out of that as well. What we would like to do with this tool, and we're starting this now, but I can't give you a whole lot of results here yet because we got to set up a server. The collaboration center means that if we've got technical reports that we've written about some aspect of the plant that ties to a data signal we see in the plant, this system will go out and grab that report and bring it back to the people that are looking at the problem, so they don't have to go out and search for it. Well, by the way, maybe someday we'll go grab the things off the internet out in the literature that's already available, because frankly, I don't think many of us are producing anything in the chemical realm that isn't talked about somewhere in the academic literature. And that's what I would like for the Collaboration Center. So I like this picture. I don't think anybody in my team wanted me to show it, but what it tells you is you have one plant right here, but you can replicate this big gray box as far as you want across an enterprise, and we're doing that right now. We have already for the process operators and the process engineers, the plant quality and plant management each have what they're looking for. It's their selection, but it's basically out of the same broad database. Now, as we get higher up in the NWA Focus EMI, we're going to try to start servicing the needs of our corporate engineering, our business unit, and executive management. We already have some tools in place that do that, but it's very manual. People have to go in and enter data, and they do it every Friday afternoon before they go home. And so in this process right here, we have our knowledge base and the collaboration center, and it's all tied together so that it's in one place. And let's see. That gets back to that picture I showed you earlier of the person fishing. This is where we're describing how we're going to get the data, what it's going to do, and who's going to get it. So our first initiative was to implement Core EMI across 12 plants in actually one business unit. We already have it turned on in a bunch of other businesses, but to get to the accelerating services, that's the pilot. Presently, we're implementing the knowledge base in the collaboration center. We started about 4 months ago. We still have about 4 months to go even now. And we will have the three plants put together. And probably very soon we'll start propagating this out across the business, which would be about a dozen plants. We have dashboards for similar plants in 2 countries. That's actually a real dashboard, fuzzy, so you can't see what we're measuring. But the calculations of relevant metrics, teaching SPC, SQC, cutoffs, and plant monitoring. We have research and manufacturing engaged in the same space with each other, and the results of that have been simply phenomenal. Detective numerous plant drifts, developed collaboration culture. Everybody's really excited about this now. And I do have some other businesses that are asking how come we're not doing it for them, but one thing at a time. Next steps, we're going to accelerate focus EMI across the rest of the company in a business-by-business fashion as they are willing to put up with this. And we're going to try to build the knowledge base and start expanding what that collaboration center can do and what the tools that are currently outside of the collaboration center, trying to get them put back in to that space. And piloting the next steps to run design. That's my code word for telling Northwest Analytics that the tool's great, but I want it to do more. And so we're going to have that conversation as well. I've got to get my company excited about this because my engineers, statisticians, can do magic with what they're capable of. We're hampered by our inability to get at the data quickly enough is the base thing. And then once we're there, I would like to be able to relieve them of the duty of much of this by using the Focus EMI and the capabilities that I hope to develop in the future to make that more applicable across this enterprise. So with that, I will stop, and thank you very much for your time.